Welcome to this course on power plants. In this first module, we will study conventional power plants, the types of systems that have historically formed the backbone of global electricity generation. We will cover steam turbines, gas turbines, combined cycle systems, jet engines, diesel engines, nuclear power, hydroelectric plants, and combined heat and power systems. The aim of this module is to give you a strong foundation in how these plants work, their advantages, and their challenges. 1.1 Steam turbine power plants. Steam turbine plants are among the oldest and most widely used forms of power generation. The principle is simple: water is boiled to produce steam, which expands through a turbine, causing it to spin and drive a generator. The process usually begins with the combustion of a fuel, such as coal, oil, or natural gas, in a boiler. The heat converts water into high-pressure steam, which is then directed onto turbine blades. The spinning turbine turns a generator, producing electricity. Afterward, the steam is condensed back into water and recycled. Steam turbine power plants have several advantages. They can produce large amounts of power continuously and they are reliable. However, they also have drawbacks, including high fuel consumption, greenhouse gas emissions, and water use for cooling. 1.2 Gas turbine power plants. Gas turbines work on a different principle. Instead of boiling water, they burn fuel, usually natural gas or kerosene, directly in a combustion chamber. The high-temperature, high-pressure gases expand through turbine blades, spinning them and driving a generator. Gas turbines are lighter and quicker to start than steam plants. They are often used for peak electricity demand because they can ramp up power output rapidly. Their efficiency, however, is lower compared to large steam plants, especially in simple cycle operation. 1.3 Combined cycle power plants. To overcome the inefficiency of simple gas turbines, combined cycle plants were developed. In this setup, a gas turbine produces electricity, but instead of wasting the hot exhaust gases, the system channels them into a heat recovery steam generator. This produces steam, which drives the steam turbine to generate additional electricity. Combined cycle plants achieve very high efficiencies, often above 55%, making them among the most efficient fossil fuel-based systems. They are commonly used in modern natural gas power stations. 1.4 Jet engines for power production. Although jet engines are primarily designed for aircraft propulsion, they can be adapted to generate electricity in stationary applications. A jet engine is essentially a gas turbine optimized for thrust rather than mechanical output. By attaching a generator to the turbine shaft, they can serve as compact, high-power units. These systems are not widely used for baseload electricity but find application in portable power generation and emergency systems, where speed and compactness are critical. 1.5 Diesel engine power plants. Diesel engines are another type of internal combustion engine used for power generation. They burn diesel fuel to drive pistons, which turn a crankshaft connected to a generator. Diesel engine power plants are relatively small and suitable for remote areas, backup power, and small-scale operations. They are reliable and easy to operate but limited by high fuel costs, lower efficiency compared to large plants, and emissions concerns. 1.6 Nuclear power plants. Nuclear power plants generate heat not from combustion, but from nuclear fission, the splitting of heavy atoms such as uranium-235 or plutonium-239. The fission process releases enormous amounts of energy, which is used to heat water into steam. The steam drives turbines just like in conventional plants. Nuclear power has significant advantages. It produces large amounts of electricity with very low direct carbon emissions. However, it also raises concerns such as radioactive waste management, safety risks, and high capital cost. 1.7 Hydroelectric power plants. Hydroelectricity uses the energy of falling or flowing water to turn turbines. Dams are often constructed to create reservoirs, allowing operators to control water flow. The potential energy of water stored at height is converted into kinetic energy as it flows down, turning turbine blades and generating electricity. Hydropower is renewable, clean, and flexible, capable of adjusting output quickly to match demand. However, dam construction can displace communities, alter ecosystems, and affect river biodiversity. 1.8 Combined heat and power with CHP plants. Also known as cogeneration, combined heat and power systems generate both electricity and useful heat from the same fuel source. Instead of wasting excess heat from electricity production, CHP systems capture it and use it for industrial processes, district heating, or water heating. CHP systems greatly improve fuel efficiency and are widely used in industries, hospitals, and large buildings where both heat and power are needed. In this module, we reviewed conventional power plants, steam turbines, gas turbines, combined cycle plants, jet engines, diesel engines, nuclear power, hydroelectric systems, and combined heat and power plants. Each technology has strengths and weaknesses, and together they form the backbone of global electricity supply.